So welcome again, everyone. We have in this course, today is day 4 in this boot camp. We have a pretty packed schedule today. Today is the day when we get code heavy. So far, you have been using external libraries. Like, for example, you use the instructor framework, you use the Llama index, you use the QTrend. There was a certain amount of coding. We were programming, for example, with instructor. We were doing many things, but we were not doing a lot of heavy coding. From today, we are going to do a lot of programmatic stuff. What I will do is frame a problem, which will be a good sort of a background or reason for us, sort of a substrate into which you will see why the subsequent topics make sense. We will talk about a problem that is historical and perhaps the most common problem in natural language processing. It is the problem of, can somebody guess what's one of the most common things you do in natural language processing? Come again? Say that, Patrick.
Name the entity value. No, training the model first.
No, natural language processing, from practical, think from a business perspective.
Conclude intent, I was thinking identify intent.
Identify the intent, perhaps sentiment, etc. Come again?
Named entity value.
Named entity recognition. Again, examples. Albert? Search in text, yes.
Hallucination.
No, hallucination is not a feature.
Translation.
That's the problem. Translation of language, yes. So, guys, what we are going to do is we are going to use natural language processing as one pin, but we are also going to pivot to computer vision, use that as another pin. And between these two pins, we are going to do a host of problems. In natural language processing, I will take a couple of problems. One of them is text categorization. Simple thing, you get text. You can categorize them into a target space, where the target space could be sentiments. It could be positive or negative sentiments. It could be emotion detection. Is it happy? Is it sad? Is it angry? Right? Is it a lament? What is it? You could classify it into a bucket of emotions. You could categorize it by topics, by subjects, right? You could categorize it by whether the level of confidentiality that you perceive in the document. You could categorize it by the level of security risk or legal risk that it poses, such a text poses. You could categorize it, more importantly, in some legal circles, by determining whether the text contradicts itself. Right? So, for example, as you know, and this is a use case we'll carry forward, in legal space, you must have noticed that the moment you want to do a contract with someone else, lawyers will be very productive. They'll charge you, what is it, $400 an hour? And in no time, magically, they'll produce a 400-page contract. Right? And you feel, wow, amazingly productive lawyer. He deserves the $400 an hour. The reality is, what's the reality? How are those legal documents produced? They're copy-paste from other legal documents, right? That is why they are such prolific writers.
So that is Conquer, right? LegalZoom does it for you.
Yeah. So so any legal contract is a pastiche of paragraphs taken or sections taken from existing legal docs. The problem that comes there is often the documents contradict. Certain sections can contradict other sections. And in fact, this is how this is the sort of fun part in corporate law. If you have signed a contract, before you sign it, you get to a lawyer and you ask, well, do I really need to, does this tie me down? Right? I want to have the other guy tied down, but I don't want to get tied down for my side of the bargain. So your lawyer will now go over with a microscope all over the document and come back smiling and say, hey, nothing ties you down because the way the contract was created, it contradicts itself. Right? And it's a fact. It's a fact in contract law, right? So usually what people look for in law is the worst case situation is you actually have to obey the contract, right? I am told that these are legal realities in US, right? And I learned about it the hard way by helping a client that this is true. So one of the questions that comes is, and it's a very valid question, can you tell that a document contradicts itself? That one part of the document, right, is completely negated by something else written in another part of the document. So that is self-consistency in the contract. Right? So you can do all of these categorization tests. You could categorize a document by the level of comprehension. Do I need to be a fifth grader? Do I need to be a 10th grader? Do I need to be a college graduate? Or do I need to be an egghead with a PhD?
So, Asif, one question.
Yeah.
That assume that the lawyer gave you went to some high priced lawyer and he gave you a contract. Okay.
Right.
He wrote you the legal document. Now, can you question this document yourself and say what are the implications of so and so, this, that kind of, can you do the LLM around it and say, have I covered all the parts where I think I have exposure to in a normal lay time way? Is that possible to do that today?
Yeah, so Sachin, the reality is historically, you would take a bunch, so lawyers sit there, and much of the work, if you go to a law office, you see that the paralegals do, right? So paralegals are people without the law degree, without the law license, working very, very hard, uh, doing the investigation for them, and you always find the law interns in the basement of every law firm doing the hard work, right? It takes an army to figure out if there are contradictions, but that's the world that's changing. In fact, LLMs, and to the extent that this course is about LLMs, you will realize that it is already one of its most successful uses is in the law, profession of law. Because law, first of all, it has two important qualities. First, law or legalese is a language of its own. It's a very domain specific language. When people speak legalese, it hardly sounds English, right? So the vocabulary is well defined. Law is the pursuit of very precise language, given the fact that language itself is ambiguous. And that's a fundamental contradiction you have in written contracts and so forth. Right? How do you search for exactness and precision of terms when language itself can be ambiguous? Now, LLMs do an amazing job actually in such a situation because the context length, as probably some of you know, the new LLMs that are coming out, for example, Gemini 1.5, I don't know how many of you know that its context length is in millions of tokens. And not only is it in millions of tokens, it doesn't suffer from lost in the middle problem that we discussed a few months ago. And those of you who are with us, most of you coming from the first boot camp, you know, we talked about this. Don't make your context input prompt too long. If you make it too long, you'll have a problem of lost in the middle. Well, that was so ancient history. That was so a few months ago, right? Or so 2023. Today, we have a situation in which the new genre of large language models that are coming out don't have lost in the middle problem. In fact, there is clear evidence, and I think we went over this evidence in one of the Wednesday paper readings, that GPT-4 easily handles input context lengths up to 64,000 tokens without any degradation or problem of lost in the middle, right? That context window is increasing. Now, Gemini at this moment, it seems to be the butt of every joke, right? Especially with this image thing that's going on. But that sort of shouldn't take away from some of its achievements. Obviously, I'm not necessarily advocating for Gemini. I believe what I say for it is a proxy for what I would say for Cloud or for any of the modern LLMs that are coming out. The context window has been getting larger and larger, and the problem of the lost in the middle is getting smaller and smaller. Today, there is clear evidence that you can feed it. For example, one researcher fed it all the person's entire lifetime of research work. And it could answer very precise, very focused questions on the entire body of 1.5 million tokens, right? Of 2 million tokens of published work without errors, almost without very minor errors, if at all. But it had very good recall and it could do an amazing job. So now juxtapose that with the legal domain. That is exactly what it is. Lawyers fail because they miss a crucial section or a crucial precedent somewhere. Okay? And so legal field is going to be revolutionized. I wouldn't be surprised if the next lawyer you meet will be a LLM. Right?
We'll still need drag because we don't want.
You need drag, of course. I mean, I mean it in conjunction with that. Right? So Patrick does have a point that you can only do it with RAG you will need. And actually, I'll let Patrick finish this point. Please go ahead.
Yeah, because they're charging by the tokens as well. So you don't want to put in the whole book if you don't need all of the information.
That is true. Yeah. So Patrick points out that they charge you by the token, the commercial RAGs. So you don't want to fit in the whole textbook for every single request. It will cost you a lot of money. That is one good reason. The other good reason is you need to force the LLM to justify itself based on facts, right? And so again, drag is important. So you do the relevant facts. You want to take away irrelevant facts and base it to that. Now, the third I mean, there's always the thing that open source LLMs are getting better and better. And if you host one locally, things obviously, then, I mean, see, the whole world is so fluid, it's hard to tell. NVIDIA is about to come out in March with new processors. The statement is that it's going to beat the H200s. Right? Well, it's nice to know that it can beat H200s. You and I couldn't even afford H100. Right? So, I don't know of what relevance it is that it will beat the H200s. But yes, the processes are getting better. A lot is happening. Anyway, coming back to today, what we are going to do. So I'll just summarize what have we done. In this course, we started out with the statement that prompting is not what you think it is. It's not your grandma's prompting. Right? So if all you're doing is writing text in ChatGPT and you think that's prompting, wake up. You can do prompting at a very serious level as a programmatic exercise. I hope we did reinforce the point sufficiently, isn't it? There is a lot we can do. Prompting is essentially zero shot or few shot learning. The moment you pose it as a machine learning activity, it's a game changer. Then we got the responses as structured data using the instructor. You could give it pydantic beans. Right? You could, well, I tend to use the word beans coming from the Java tradition, but pydantic base models or data models, or pick your word. If you see me say beans, think of it as data models. So you can give it pydantic data models. You can ask the LLM to populate the data model. And as it populates the data model, you can put validators. Because Pydantic supports validators, you could give it validators to ensure that the response you got was right. If you didn't get it right, you can force a retry, as many retries as you want. Now, what's the relevance of that? LLMs, as we remember, are stochastic machines. To the extent that we sample off the softmax layer, at the tail end, if you remember, we sample off the softmax. What does sampling of the softmax do in the tail layer? It leads to unpredictable, like it's no more a deterministic machine. It becomes a stochastic machine, right? Which is why a lot of people use the word that LLMs are stochastic parrots, right? You ask it for a story and you ask for a story again, it will produce a different result. Or people often say, well, I can set the temperature to 0. What's wrong with believing that you set the temperature to 0 and then it becomes a deterministic machine? Anybody would like to give an answer to that? Sheila. What's wrong with setting the temperature to 0 and hoping it's now a deterministic machine? The reason is, even at 0, it still samples. Actually, it's not 0, temperature 0. It is 10 e to the power 0. Right? And you're still, so all it means is that you're not scaling down the softmax largest, right? The softmax largest are probabilities that you're producing, and you're still sampling off the probabilities. So as people learn the hard way, it still remains a stochastic machine, isn't it? So that's an aspect of it. So if it doesn't produce the answer that you want, you can always retry. The other thing that instructor gave you, if you remember, was it gave you a post validator, a LLM validator. So for example, you could put a validator, which you can't, with Pydantic you can't, which is to say, you gave me back the text, but the text should be understood by a 10-year-old. And as you will see in the solution to the textbook problem, which I suppose I'll give up and release now, because there's still half the class who haven't finished that assignment, but okay. You will see that one of the most effective ways to ensure that the answer given by an LLM on a very technical topic is understood by a 10-year-old is to do a LLM validator on top of it. And if it doesn't produce what you want, you reject it. You say, try again. And when you do it like that, you tend to get very useful results. To wit, for example, your project was create a 100-page textbook on a relatively technical topic to be understood by a child. Right? So you realize that that's tough. That would be very tough even for professors. Professors have a hard time bringing down their knowledge to college-level students, even when they're teaching in a lecture hall, far from bringing it down to 10-year-olds. And it's a remarkable feat that the LLMs can do that. That's what you'll see in the solution. So that is one. The other framework that I ask you to look at is DSPY. Right? I don't know how many of you got a chance to do that, but I'll just summarize it in a very simple way. What it does is, and this is all a movement from just plain text prompts towards a more programmatic approach, right? Doing it through code, imposing a certain structure, and going back to the fact that at the end of the day, prompting is few-shot learning. And so it is most effectively done through programming rather than through just entering long-form text. Right? So DSPY, if you haven't tried, if you haven't read the paper, please do that. I will. In fact, it's important enough, and I regret that I missed that covering that paper. I'm going to do an extra paper reading session off band, like not on Saturday, but let's say on Monday or Tuesday. I'll announce it and I'll cover that paper anyway. Right? So it's an optional thing. Come by if you can, attend that paper. We'll do that. Now, so you can use DSPY. It will compile it. It tends to produce much more efficient prompts, and you can run with that. Albert.
So this DSPY, is it addition to the other framework?
Instructor
framework.
Yes, these are all complementary things. They work together. You could do that.
Can you repeat the name of the framework?
DSPY, it's there in yours. So guys, now our course portal is back. If you go and look into our assets that are here, you will find that here it is, DSPY. Right? The next thing that we talked about in our engagement with prompting, there were two more things. One was chainlet. The chainlet was a great way to create chatbot applications in an efficient way, isn't it? And I asked you to do that with the Old Faithful geyser. Okay. Now, I hope you did this. By the way, let's go and see if this comes through. Okay, I have to upload the file now because the file is lost. I think I gave you guys all the file. I'll upload it. This is your starter code, which again, file is lost because we just restored the website. I'll upload all of this information shortly. The starter code and everything. DSPY. The next thing we did after Chainlit was AutoGen Studio. What was the point of AutoGen? It was the multi-agent nature of things, right? We wanted to see when you want to verify something, if you go back and ponder, how can you reduce hallucination? Or how can you make an LLM produce factually correct things? There are many ways to do that. One of the ways, and all of it ultimately boils down to the fact that in machine learning, discriminative models are generally far stronger than generative models. Right? It's far easier to classify text into, I don't know, poetry versus prose than to make a generative model produce the next Shakespearean sonnet. Yeah? Generation has always been a bit harder. And to the extent that the only trick we know for generation at this moment is next token prediction. Right? Generation is perhaps an inefficient, slow, error-prone process. So what can you do? You can use the LLM to critique itself, isn't it? To apply its own discriminative ability to determine whether it's right or not. So how do you make an LLM critique itself? You can make it wear different hats. Right? You can do multi-stage prompting. You can say, generate this. First, let's say you are the professor. Generate a question, right, with multiple choice, or generate an answer to this question. Then you can have a critique. The same LLM where a critique's role, change its role to a critique, and with the critique, ask it to evaluate the truthfulness or correctness of the statement, or to find gaps in the reasoning. Okay? And by forcing it to find gaps in the reasoning, you can determine whether the statement that came out was correct or not. So you'll never be sure, but it goes a long way. In fact, you know that you guys have all been going through the quizzes. By the way, the quizzes also are restored now on the portal. And you also know that the quizzes that you are getting, I generate it using AI itself from the lectures that I'm giving. Like, for example, this video will soon transmute itself into a quiz, right? Or for a review. Those quizzes are automatically generated from this. How do I know that the answers to the quiz questions are correct? There is an interplay between different agents. I have an LLM generate a question, multiple choice question. Then I have another LLM look at one aspect of it. Look for ambiguity in the questions. Right? Then I have the LLM so that is linguistic ambiguities. So I make it wear a linguistic hat or clarity, make it into a copy editor of sorts and language editor of sorts. A check for clarity in the language. Then I make the LLM wear a subject matter expert's hat, right? And argue for what the correct answer is. Are we together? Then I make it wear another subject matter expert hat. The same, take two subject matter experts and have it answer the question. If they are, why? Because, you know, if it is a stochastic parrot, who knows what it will answer the next time, isn't it? I make it wear the other hat and argue for the correct answer. If both times it can argue for exactly the correct answer, and if it can also argue that there is no ambiguity in the question, then it becomes a question that survives in your quiz. Right?
Asif,
Yes.
Asif, just for my understanding, we are making LLM wear different hats, and that's quite effective, right? And why is that we have to make? I mean, like, why is it effective when we change the roles? And
Yes.
Yeah.
Yeah, the reason for that is, look at it this way. When you give it an input, at the end of the day, if you treat these machines as not carrying a context, like from conversation to conversation, you make it a complete, like think of it as one atomic transaction. You say, you're now an expert who has been working, who has been a co-author in this paper, research paper. So what does the LLM do? It says, okay, I am one of the co-authors of this paper, right? And then you say, given this question, what is the correct answer from your point of view? You see that, right? It will completely focus on answering it that way. Now, you ask it, you are an editor of a textbook. Your task is, remember, following a core-star framework, your task is to look for ambiguities. Your goal is ambiguities in the language and whether the question or the text can be reformulated in a better way, less ambiguous way. For that transaction, what is it? It's complete attention. So remember, it is all attention based. Right? Where is its attention now? Where is its focus? It is on the language aspect of it. So why does it work? To your question, why is it that you can make this language model put on different hats and work? There are many hypotheses. We don't fully understand it.
I see.
But here's my hypothesis, Jay. See, within a large language model, there are subnetworks. Remember the lottery hypothesis? Do you remember me covering the lottery hypothesis? Any one of you? No, I did that in a research paper reading. So, okay, let me talk a little bit about the lottery hypothesis. See, in a very large network, any bit of information can be, or any particular area, when you train, you don't need the entire network of all its weights and biases. Are we together? That network has bizarrely high dimensionality. It has too many parameters. So what happens is that a subnetwork trains itself on that part. Are we together? So internally, in a very vague way, in a way, sort of not too vague a way, but reasonably, a large language model internally behaves like a committee of experts, right? There are subnetworks in there that remember certain things, not the whole network.
I see.
Right. And so when you make it wear different hats, one can imagine that different subnetworks come forward and respond to your question. Right. And that is what you're doing. So once you remember that whenever you give it a generative task, only from this large language model with its hundreds of billions, let's say a trillion parameter, only a subnetwork is effective. The moment you have that realization, right, for that task, you can ask, why can't I use the other subnetworks in the system to reinforce and improve this result? And that is the gist of what we are doing.
Thank you, Asif. I think that is very helpful.
Does it happen at training time? Do we have a different perspective or define the subnetworks?
No. So Prasad's question is, at training time, do we know which subnetworks are active? Even if you could, it's not worth it. These LLMs are very opaque. All we know through empirical evidence is, and maybe let me do one thing. Let me do the lottery hypothesis and that group of research papers again. But the point is that whenever you train a machine, it will self-differentiate itself. Think about it this way. If I had think of common normal life. If you wanted 1,000 people to build cars, would it be useful for each of the 1,000 people to learn all the skills in building the car, like making the seat, making the roof, making the tires, making the engine, the crankshaft? You wouldn't want that, the gear system. What you would want is the most efficient utilization would be for it to develop, for that whole group of 1,000 people to develop a specialization of labor, isn't it? In fact, industrialization, efficiencies, the scientific, if you look at scientific management of the production flow, implies, foundational to it is that you create specialization of labor. The guy who does nothing but makes a bolt and the threading on the bolt will eventually become very good at that. So now ask yourself this question. When you are feeding an LLM with a vast amount of data to train itself, within it are a vast variety of tasks. Those tasks span, many tasks, right? For example, and today we'll cover the BERT paper, you'll see it. There is next word prediction, finding out text categorization, contradiction, this, that, translation. Does it make sense for the entire network to learn everything? Or if it could internally, effectively partition itself into subnetworks, right? To effectively develop specialization of labor. Common sense says that the most efficient learning that can take place is if subnetworks became specialists at tasks, isn't it? And therein comes the benefit that you can, one way to utilize the network much more fully is to make it wear different hats. Make the same LLM, I'll come to you, Krishna. Make the same, Arul, I'll come to you, 1 second. To make the same network, by making it wear different hats and looking at the problem from different aspects, all you're doing is you're getting a greater utilization of the training that this network has gone through. Is it making sense? Right?
Yes.
That's why we do the multi-agent aspect of it. Yeah, I think, go ahead. Somebody remote had a question and there are a lot of questions in the room. Go ahead. Somebody on Zoom?
Asif sir, so when you say sub networks are there and those get attention when we create a hat, but so these sub networks eventually get created when the LLM was first created with a lot of data, or even it depends on the data we feed in and create tokens there, or how does it differentiate? Like,
see, the way it works, and it's a little bit more subtle. What happens is when you give it an input and you see which of the neurons are getting lit up in processing that input, you literally see that a large number of neurons are dormant. Right? A lot of the, it is actually a sparse matrix that's processing any given input. From that, you infer that somehow the machine knows that for this part, this subnetwork internally is the one that should lit up. Now, when you say lit up, it doesn't mean that the other ones are absolutely at zero activation. It's just that their activation potentials are infinitesimally small. They're very, very small. But a subnetwork is much more lit up. And you can't control that. You can't hand enforce that. Right? It is how the system learns.
even if it is domain specific data, the whole LLM is trained, even then it can
It will do that. Yeah, it will do that. It will always try to create specialization. See, it's just human beings, right? If you throw 1,000 people to do a task, a complex task, the first question that a good management layer would ask is, can I create division of labor and specialization of skills? Isn't it the most obvious question you would ask? Right? Division of labor and specialization is at the heart of the scientific method of management. And that is the closest analogy I can give you as to why you notice that as you train this very large transformer networks, you see a similar behavior take place through backpropagation. Somewhere it picks up the fact that it's a good idea to do something like that, something analogous to that. Now, is it making sense, guys?
Yeah,
Definitely. Thanks.
Yeah. So I think in terms of LLM wearing the different hats, so I'm thinking from that perspective, either you can make that happen in one prompt, a series of or with the different agents. Both are
right.
approaches.
You
right?
can do that. Generally, single shot prompting is something I advise people not to do. As you notice, I've been telling you guys that do multi-shot prompting. Right? Give a prompt, get the response, go to the next stage. Again, not multi-shot, multi-stage prompting. Do multi-stage prompting. Go through a whole iterative process. You're less likely to hallucinate. You're less likely to go wrong. You're more likely to have a robust solution from that. Right? And see, hallucination is a real problem, or it's a real opportunity, because the creativity of an LLM comes from its hallucination. If you remember in the fun search paper, right, we leveraged that, created good algorithms by leveraging the hallucinatory ability of the LLM. In the alpha geometry paper, research paper, again, the LLM achieved Olympiad level math ability because it could hallucinate. Or be creative rather, it could create it. You just need to couple it up with a framework that utilizes it rather than lets it get derailed. Isn't it? Arul, you have a question.
Yeah, my question is like, weights is like, it's learned knowledge, just creating this person or multiple people of these different knowledges that they actually do over a period of time and continuous training and stuff. And bias is kind of gives them the character. That's how like.
No. Weights and biases are the same thing.
I mean, like sort of. But what I'm saying is, okay, it's the same thing.
It's the same thing. I wouldn't distinguish it. That's why you use the word parameters, but it has become very fashionable to say weights and biases. So the only difference between weights and biases is a weight is influenced by the previous input coming in from the previous layer. The biases are sort of fixed. So think of a transistor. In a transistor, what you have a bias there, right? Voltage there that determines how much current will go through. But it's usually the opposite. In a transistor, the top voltage remains the same, right? But actually, the signal comes from the bias end of the transistor. Right? The roles are somewhat reversed. Right? Sanjay.
When you have this multi-agent different personas with their own prompts, and can you talk about a little bit how this communication between those happen? Is it the libraries that are doing this? Or
yes.
If I'm not using the library, then if I just go to look at the core model, then I have to.
You have to do that. So Sanjay's question is, how do you make sure that these personas can interact with it? And they are obviously, that's why I gave you guys the AutoGen Studio project, which, how many of you tried that, by the way, AutoGen? Many of you tried it, right? So more of you need to try it, guys. Huh? Because that gives you a structured way of keeping track of what one agent said to another.
So you have to literally then, if I don't use AutoGen, pass the output of one to the other.
To the other to do that, yes. And based on that, there are many such frameworks. If you remember, we covered the simulacra paper. Do you guys remember we did the paper reading for simulacra? Yeah? A landmark paper, by the way. It has far-reaching consequences. We did that. I hope you remember that. The video is here. The quiz is here. If you haven't done that, now I hope the quiz is also here. Yes, it is here. Let's see how many of you did the simulacra quiz. Quizzes.
I still cannot log in into SV.
We don't like you. So, oh, there are only 6 attempts, guys. Arul, I'll come to you. 1 second. There are only 6 attempts, guys. Please go take the simulacra quiz. The video is also there. I'll post the video for simulacra. It's an important paper, but what was the lesson, Sanjay, to your point of simulacra? What you would do is each person living in that little village would remember what was happening, what others were doing, and it would reflect upon its own action. So it would act, but there was a reflective ability. Just like human beings, it would then reflect at what it had done and come to a higher level understanding of its actions and others' actions. And the consequence of that was dramatic. If you notice, in the simulacra paper, much of human sociology, much of human behavior could be very faithfully reproduced, right? And you see that with such small primitives, act, reflect. Reflect upon what? a continuum of actions, right? And so store it, but the framework stored it and then gave it to the agent and said, you are this. So for example, you are the librarian. You are the person standing for politics, election. You are the school teacher. You are the researcher. But each person would be given, this is what you did. This is what somebody said to you. Now,
these things are also literally hardwired, or because there is a back and forth that needs to be dynamically.
No, it is all dynamic. Nothing was hardwired. In fact, all you gave is in the simulacra paper, I think, just to whet your recollection, guys, watch that video again. You'll realize that all you hardwired is personalities. Very much like human beings, we get or we come born with certain personalities or we inherit it from the conditioning of our cultures. By the time we are 18, about most human beings, you can predict which way they'll vote, what they will do for the rest of their life. There's a certain hardwiring. And so all they did is that they programmed certain personalities, I believe a dozen or so personalities, 20 personalities. Right? That was the only prompting that was given. Then they were asked, okay, what do you do? Time is 9 o'clock. And you literally, or 6 o'clock, and you could see that one person wakes up at 6, another wakes up at 8. Right? One focuses on studying, is a student, one focuses on research. And their actions spilled out. Why? Because LLMs have natural creativity. That is its inherent quality, right? Remember, what was the whole point of adding sampling to the softmax layer? To inject that creativity into it, that stochastic behavior into the LLM. And that is remarkable. The results of that were remarkable in the simulacra paper. Recently, from Meta came out a paper called meta prompting, right? And then actually meta prompting is problematic because there's so many research papers now titled meta prompting, it's hard to tell which one we are talking about. But if you go back and look at the meta prompting paper, you'll see exactly the same role playing. You make the same LLM wear different expert hats. You make the experts argue with each other. And from the argument, you have a meta expert that draws conclusions. What am I doing when I'm making your quiz? Exactly that. I am taking, I have a overall person who's orchestrating the creation of every quiz question. In that process, I'm making a linguistic expert, New York Times editor kind of personality, looking for the clarity of language. I have a subject matter expert who apparently has written that research paper. I have yet another personality, which is a student, right? Who is the subject, who is the audience for that paper. So if you think about the CoStar framework that I taught, in which I said, audience, who's your audience? But the next evolutionary step of the audience is you literally have the audience in the room arguing and deciding whether I like the question at all or not. You see that, right? What is this? This is multi-agent behavior, which is why I hoped that, and I still hope that you guys will take the AutoGen project very, very seriously. Create your textbook and these projects. Use the AutoGen to do that. Are we together? And use it to great effect. Now, the problem that I gave you with AutoGen, just to recap, the project was, does anybody even remember what project I gave you? The rains have washed out all memories. The project that I gave you, and guys, do it, because once I release the solution, you know that your learning will get impaired. All you'll do is read the solution. Yeah? Which is why I'm hesitant to release the solution movie. But it's a complicated piece. What I asked you to do is have a professor pose a question, multiple choice question. Then you play the role of a student, the human being. The professor's job is to pose a question that is so tough that the student cannot immediately answer that question. The student needs help, needs to go through a thinking journey to answer that question. And that question has to be related to or derived from one of the 400 lectures that I've given, isn't it, over the last 2-3 years? Then the professor poses that question. The role of the professor is to make sure it's not easy, but it's answerable within the scope of everything that I've taught. Now, other than it is very evident that only LLMs have a context window of 400 videos. Clearly, you guys don't even remember that we did the simulacra paper. Right? So we need to brush up. So anyway, so then what is the role of the teaching assistant? The student can go to the teaching assistant and ask for help, the tutor. What does the tutor have to do? Bad tutors do what? Give the solution. They impair the learning by just giving out the solution. Right? What was the tutor supposed to do? The tutor was supposed to help the user go through a learning journey, thinking process, step-by-step reasoning process. Literally go through a chain of thought in some sense, isn't it? But not give it the answer. You have to lead the horse to the water. That's about it. Okay? But wait for the student to then get the answer. In other words, and when you see the solution, you'll realize that this is exactly what, for example, Khan Academy did with its Khan Amigo. Okay? And what I wanted to show you in the last project is it's actually fairly trivial to be able to build something like that.
Wow. And this we use AutoGen, is that what you said?
AutoGen. Do that.
Okay, perfect.
Yes.
So I said this whole concept of the LLM agents, it's just text entering an LLM, throwing out this text into another LLM. And
yes.
Depending on how.
And you have some way to orchestrate the flow of information, programmatic way to manage the flow of information.
So the frameworks only orchestrate this movement.
Yeah.
Output, input to output, input.
Exactly. And at each moment, use its own, because the orchestrator is a LLM too. It has to evaluate whether we have reached a contradiction, right? And things like that. Albert,
so
no, hang on.
Orchestrator is implicit in this.
Come again?
The orchestrator is implicit.
No, orchestrator is a LLM role too.
That's also.
Yeah. So in the problem that I gave you, you needed only two agents. One was professor, one was the tutor, and the student would be you, the human being. Okay? So there was implicit orchestrator. Sorry.
So can you use simulacra and the AutoGen framework to stop prompt injection attacks? Is that possible?
Saurabh has asked a very good question. Can we use simulacra and AutoGen-like framework to prevent prompt injection attacks? See, prevent is a strong word because that needs a mathematical evidence that it blocks out 100% of it. Let's just say that it mitigates it to the extent that for all practical purposes, you'll make it very hard to do prompt injection attacks. Right? See, I'll come to you, Albert, one second. So the reality is, security is all about making it expensive or hard for the attacker. That's all you can do, right? Like your house, right? You put a stronger, bigger door, like a lock. Why? You think your lock stands up to anything? No. I mean, if nothing else, somebody can come with an axe and break your door down, right? If the guy is hell-bent about entering your house, you're just prompting the guy who comes there that this door may be harder. There is an easier door to break next door, right? So you're basically gifting that thief to your neighbors. You're not preventing theft. There was a very good documentary I once saw. People got very carried away because nowadays they are manufacturers of bulletproof doors. Right? And then they did a survey of people who had put bulletproof doors in America. And they realized that most of those people didn't realize that the door was attached to a wall, a frame, and the wall was still made out of sheetrock. Right? So you could literally punch your way through the sheetrock and enter into those people's homes. This is the reality. What's that?
This is like having a window.
Having a window next to the steel door. Yes, exactly. Right. So that's the nature of security and defense. You have to look at the weakest link. always. Yeah, Albert.
So, suppose you build a software against an LLM. How do you make sure that software works under if you have a different LLM? Like think of the LLM might change. How do you predict that will always work? Right. So today it will work, tomorrow it may break.
Albert's question is very good. So Albert raises a very interesting question. It is about the uniqueness of the LLMs and their strengths and weaknesses. Right? It is a real problem. Nobody has a solution. The fact is, every LLM has been trained and comes with inherent way of behaving, its own strengths and weaknesses. And people have learned the hard way that when they swap LLMs, they have to rewrite a small, not all of the code base, but they have to question some of their assumptions and redo things. Patrick.
I think that's what DSY is trying to solve.
Exactly, that's what DSPY framework. But guys, I have to get you to, I can stand here for 8 hours and go on talking, but unless you do it, it's a boot camp. Unless you do it, you don't even know the frameworks I've put in front of you. So guys, this is a catch-up time. I'm going to today make sure and come to your rooms and make sure you guys are doing it. Right? So we have to do that. All right, so go ahead. Go ahead, somebody remote, Jai?
It's just a question. How do you come to, like this AutoGen or, other kind of DSPY? How do you get to know this?
Oh, how do I get to know this?
Yeah.
Many ways. So here's a simple way. Every day, wake up, go to archive Saturday in the morning. Don't listen to junk like your local news, YouTube. Just turn off Netflix. The first thing you can do is just cancel your subscription to Netflix and Prime. Get that, right?
Okay.
Every day, wake up. Instead of reading New York Times or whatever trash goes for news these days, go to Archive Sanity.
Okay.
And look up the papers. All the best papers are mentioned there. You can't read every paper, but you can read those papers. Then there are, so I can talk about it. I go to Archive Sanity, that is one. The other thing I do is there are a couple of YouTube channels which immediately latch on to whatever big breakthrough happens. And some of them are very good. For example, there is a lady who makes very good videos called very accessible and easy to understand videos. I think it's called Mrs. Coffee Beans. Yeah, Letitia. So I would say that if you want an easy ramp up to the latest that's happening, just watch her videos, Letitia's videos, Mrs. Coffee Beans. The other is Yannick. Yannick is a little bit more technical. If he comes up with a video, you must watch it. Right? Basic rule, you must watch those videos. The third is if you have Spotify and so forth, there are a few podcasts. One of them is literally called AI Breakdown. Every day or every other day, there is a podcast that summarizes all that is happening. But that is more from an end user perspective, what's happening. Like, for example, the moment Gemini gets into trouble, you'll probably know it within a few hours.
What's the podcast?
The AI Breakthrough, AI Breakdown, AI Breakdown. That is there on Spotify, I get it, usually. Right? That is there. Lastly, of course, my secret is a way of learning is to learn from you guys, because we are a learning community. Whatever happens, you guys will talk about it. When you talk about it, I hear. Then I go and study it.
LLM bootcamp.
LLM bootcamp. LLM bootcamp is my way of learning.
If you don't want to use AutoGen, you can use another framework. It's called Crew AI.
Okay, Patrick mentions that there's another framework called Crew AI. Okay, so you could use that. I'll explore that. It says, see, this is active learning. I just learned something, Crew AI. Okay, guys, so now we need to move forward. After prompting, we did a lot of prompting, and then we said, let's go and do RAG, right? So we did some advanced prompting and so on and so forth. By the way, it's amazing. Actually, as you know, I did research on quantum chromodynamics, right? quantum field theory. I couldn't imagine that I could ever explain it to 10-year-olds. And yet the LLM is able to do a very, very good job of it. I'll release the solution. You can do that. And our next topic was RAG. RAG is something we did in the last boot camp, retrieval augmented generation. To summarize, what are the key values of RAG? Key value of RAG is, first of all, LLMs are never current because they have a date on which they were trained, right? They're horrendously expensive to train. To train an LLM takes months of effort, takes enough electricity to light up an entire city, mid-sized city in America. That's an electrical consumption. It's an environmental disaster to train an LLM. Right? Once an LLM gets trained, the hope was that it would become a community resource, but these days it has become a company's moneymaker. But it is so. The trouble with LLMs is that if you ask it what happened yesterday, it won't be able to answer. Right? That is one. The other thing is they hallucinate. Right? And their knowledge is too broad. And the third is most knowledge is locked behind is the dark knowledge, the corporate knowledge. The LLMs have not learned from the body of facts and documents and tech support documents and manufacturing manuals of Boeing, right, or Lockheed Martin. Yeah. They haven't. They simply cannot. Not because they are not for any of these, right? So you can't ask it a question about F-35 or something like that if you're working in one of those companies. But how do you use a LLM to still be useful, for example, to the employees of one of those companies? So the answer to that is you can RAG it. Namely, you can couple a search engine which dips into a body of knowledge that the LLM has not seen, inject it into the prompt. You say, these are the facts. Given these facts, now, and based on these facts now, go answer this question. Right? That is RAG. When you do RAG, there is also the problem. It may still hallucinate, or it may produce an answer that is from the parametric memory. So there are tools. One of the tools that I introduced you to was RAGAS. Yeah, and there are other tools which try to ascertain whether the answer came from the retrieved knowledge or did it come from the parametric knowledge of the LLM. What's the parametric knowledge? The weights and biases. What is stored in the weights and biases of an LLM. As you know, it came as a surprise to researchers that these LLMs actually can memorize. The whole idea was that they shouldn't be able to memorize, but they do memorize facts to the extent that they regurgitate the facts near perfectly. Right? This is, of course, the famous case that New York Times has against OpenAI, because they showed that OpenAI, under the right conditions, can pretty much regurgitate the New York Times articles when prompted. And how does it do that? We don't fully understand, but it does that. Right? Now, well, we have some understanding that it has a huge parametric memory in which it can store all of that is there. There has been a paper that systematically can extract a lot of facts, training data at scale from our LLM. It's like a child. Everything the child has heard, it will blurt it out. So that brings up another reason for RAG. Or why do you not want to train an LLM on your private data? Because it's a child, it will blurt it out, isn't it? Somebody with access to your LLM, if you fine-tune an LLM on your data, sooner or later somebody will figure out a way to make this child blurt out all those secrets. You can't think that I trained it privately in my dark room inside the company, behind Fort Knox security, and just because that data and the training happened privately, the LLM, and LLM, of course, doesn't have access to that data anymore after the training, that the LLM won't blurt it out. It will, because it has a capacity that we don't quite understand how, but it does manage to remember and blurt it out. Right? Which is an argument against fine-tuning it on any proprietary data that is sensitive. It's very important not to train an LLM on sensitive and proprietary data. Arun?
Two questions. If we take an open source model,
yeah,
and I train it and fine tune it for my specific task, most of them are Apache license Am I supposed to post it back or?
No, Apache license does not require it to. Apache is very commercial friendly. It says you take something from the Apache license and you fine tune it. You have no obligation to give it back to the community. If you give it back, good for you. If you don't,
especially if I'm training on my private proprietary data.
Yeah, you don't have to release it back to the public at all. Don't. Just make sure that your engineers don't have a habit of posting it to Hugging Face Hub.
Can you use it for commercial purposes?
You can use it for commercial purposes. Apache, you can. A GPL license, you can't. Right. So anyway, that's a licensing thing. So guys, another reason for RAG is RAG represents an alternative to fine tuning, isn't it? Because if you show it only in the context window, only in the prompt, these are the facts. Based on this facts, now respond to this question. Right? So when you RAG it, the model at that moment is not being trained. Remember, it is an inference mode. In inference mode, it has no capacity to learn.
Asif, can I ask you a question?
Yes.
I know you don't want to talk about the licensing, but is there some time in the future, near future, could cover some of these licensing aspects of all these packages we've been playing around with in the context of two reasons. One, many that are going through this boot camp are trying to build their, own proprietary stuff. What does this licensing mean? And also from an enterprise perspective that many of us will be dealing in that context. If you could cover that would be great.
Okay, because it's a little bit off topic or tangential, but still relevant. So I'll give a very short blurb, and I can talk about it at length separately. Here's the reality. See, licensing is critical from a legal perspective, right? For example, if you use GPL code, GPL software, you're obligated to return it back to the community. There are two schools of thought. One is open source, and the other is Free Software Foundation, FSF. Right? At the head of Free Software Foundation is Richard Stallman, a great luminary who's completely anti-property rights when it comes to software. He believes that research ideas should always be open. That's been the tradition in the Western Hemisphere. But software belongs to the category of good ideas. And so you should just people should write software, and the moment they write it, they should give it back to the community. If they take from the community, they must, and use that as a foundation, they must give it back. Right? So that is the GPL license. At the other end of the spectrum are obviously commercial people. So commercial people says it's okay for us to take from outside, but not okay for us to give anything back. Okay? So which is the reality? So for example, any company that you look at, I looked at Oracle, for example, internally, it's a fact. I mean, it's not a hidden secret. We use thousands of open source libraries. The only constraint is just make sure we don't use anything GPL, right? But of course, do we give it back to the community? No, that's not how commercial companies work, because our obligation is to the stakeholder, to the stockholder. Like, we are a commercial entity. All companies will tell you the honest truth. They say that our dhamma is not to give back ever, right? So that's that, because that is contrary to their maximizing stockholder value goal, which is their real dhamma. Then in between are these organizations that say that let's create an ecosystem that everybody benefits, and we make it an act of good faith to give back to the community, which is the Apache in between. And then they have MIT license and BSD license and things in between. But generally, Apache is very open. It goes with the fact that, see, let's keep things open. Anybody can take your work, do whatever they want. They can, derivative work they can keep to themselves. Though the hope is that human beings have a reciprocity. If we take something, suppose you give me lunch, what is my first reaction? To give back something to you. So Apache license essentially banks on the fact that if you take something, you'll feel like giving back. Does it always happen? It doesn't happen to people's great shock. For example, as you know, Amazon made it. There was a landmark article that at one point New York Times wrote about Amazon. that was titled something like Strip Mining the Open Source. So what Amazon did as our first cloud provider, and I believe now all the other cloud providers are probably doing it, I don't know, but it was about Amazon. What they did is they took all these Apache license things, right? They made them as service in the cloud. They charged the customers for the service, made a ton of money, and made close to zero donation back or sponsorship back to the open source projects. Right? And then one company that got really mad was Elasticsearch. Right? And they said, well, come on, at least give us some sponsorship money, something back. And Amazon said, we don't have to. When Elasticsearch made a big stink about it, they cloned the software. They just cloned it, forked it, and now they call it OpenSearch. So if you go to Amazon, OpenSearch is optimized, I'm told, but Elasticsearch is on your own. Right? And one easy way the cloud providers do to make their own offerings, expensive offerings, look good is they'll make sure that their offerings will be totally well-tuned, but the open source offering, they'll support it and run it with the default setting. Default setting is a setting that's meant for a laptop, right? And they'll say, okay, you can go into production with these settings. Right? So I mean, obviously, it's a pretty nasty game. And I don't want to talk about licensing anymore, but those considerations are all there. So look at this, for example, since we are talking about that, and I'll close that topic because I want to move on to today's stuff. Look at Mistral, right? Mistral is, at this moment, people are seriously asking whether this whole Mistral was an exercise in astroturfing, right? What they did is, when Mistral came out, the first thing people noticed, actually, I couldn't help notice that after a long, long time, perhaps the first time that I ever read a research paper, which had text art, like colorful Mistral in 3 dimensions as the title. Literally, go read the archive paper. It is almost hilarious to see the title of the paper. Then that paper is devoid of any facts. It just says, okay, we are Mistral, we are great. Right? And they released a model in which they gave you no details except just the weights. They didn't tell you what data it was trained on. They didn't tell you anything, what they did to tune it, to optimize it, anything. They just say, okay, here's the model. They just gave you the weights. And then they say, oh, you know, we are open source. Right? There was nothing open source about it. Right? It was just open weight. And then it turned out that the French government, like when the European AI Act was being created to protect the rights of the people, the French government intervened and said, we don't like some of the clauses, right? And because it will hurt our own AI effort. In particular, it will hurt the effort of the Mistral team, right? So the European, you know, because everything is negotiated, there were some allowances made for this in response to the French government. And then it turned out that Mistral has now just done a big deal with Microsoft, right, to host everything in the Azure cloud. And now people are asking whether Mistral was really ever was in good faith open source, or was it just astroturfing as an open source? Right. So licensing is a complicated business, and who knows? Who knows? See, I don't want to ascribe malice to Mistral. Who knows? This is just the practical realities of getting funding and surviving. That's the reality. So licensing is complicated.
Thank you, Asim.
So, guys, you know, we live in uncomfortable times. You remember the Animal Farm? You remember the story Animal Farm, George Orwell? At the end of it, the pigs are more equal than us. Right? All people are equal, but pigs are somehow more equal, right? And so we live in a world in which and at the end, the way the story ends in Animal Farm is the sheep still remember the old song of freedom, but they have lost their freedom. Right. And so open source world is a little bit like that. It's an aspiration. We all aspire to knowledge being free, to it being shared. Reality is, who funds open source projects? Companies do. Right. And companies' goal is to maximize their shareholder value. So it's a tough world, you know. It's still, you know, with all its imperfections, open source is great.
Mistral is fake.
Was that?
is funded by Microsoft.
Yeah, Mistral is now fully funded by Microsoft.
And then they are sharing OpenAI too.
Yeah, and look at OpenAI itself. It started out as an organization that would be a countervailing force to Facebook and Google, who were holding on to secrets. And then, as Elon Musk in one interview said, the OpenAI is the most closed, most profit-minded company ever.
He's suing right now, actually. He's suing.
Yeah, and he's suing OpenAI. And not that Elon Musk himself smells of roses by any means. Like, he's a character. He's a weird character in his own right. Anyway, so that's the crazy world we live in. You know, it's fun actually to see all this colorful and picturesque characters. So, all right, guys. So we moved to today. So we did RAG, retrieval augmented generation. We saw its value. Its value is that you can augment the knowledge, not just augment the knowledge, you can make it current. You can make sure that your knowledge is not stolen, because the alternative is fine tuning, which can be dangerous on proprietary knowledge, right? And other things. RAG can be used, especially in a multi-agent setting, to mitigate hallucination to a large extent, right? By forcing it to produce evidence, or by citing from the search results, for every statement that it makes, and so on and so forth. So if you remember, we did the paper Augmented RAG last bootcamp. So all of those reasons. So that is a summary of all that we have done so far. Your last project was to implement RAG using Llama Index. Llama Index, right? And as you notice that when you use Llama Index with QDrent as your vector database, the entire LLM1 bootcamp project becomes much simpler. Then why did we suffer through doing everything by hand? Because that's how you learn AI, when you build everything from the ground. Right? So in some sense, this bootcamp, if you know, has been programming light so far. We did prompting. Prompting was programming, but not very intense programming. We did RAG, but we used Llama Index and QDrent, which is like using third-party tools to get the work done, libraries to get the work done. That is the state of the art. By the way, I want to hear opinions about Llama Index. How many of you liked it? Very good, isn't it?
It's pretty good, but I'm sitting here struggling to figure out exactly what's going on with like some of the integrations to other libraries. So.
Yes, Yashika made a very good point. It's very good, but she's struggling to figure out what exactly is happening with some of the integration points. And I'd like to dwell on that a little bit.
I had the same question.
You had the same question. See, guys, every time you use somebody else's library, it is never an unmixed blessing. It always comes with problem. In the beginning, it looks very nice to use those libraries. At the end of it, it always ends up in tears, right? You end up losing most. What remaining here, we middle-aged men are still left with on our heads.
It has compilation problems with different versions of Python. So
yes, it has Python issues, it has problems, it has many things. So guys, here's the nature of open source. People are doing the best they can. With limited resources, they can support only those many platforms, those many versions of Python, versions of libraries, etc., etc. And so a lot of it is that, you know, the open source attitude. If it breaks, why don't you write the solution and contribute it back to the community? That's the usual approach. And things will evolve and it will get better. But generally, using Llama Index is a good idea, but it puts you into a straitjacket. The only tools you can use is what it has, right? And if you want to extend beyond that, you have to know how to extend beyond that. It's not that easy. Whereas the way we did the bootcamp ourselves, if you remember, you built everything by hand. When you build everything by hand, you're in total control, but you have to work much harder. Right? So if I were to ask you, how much value was it to use Llama Index over what you had done yourself? What would be your answer? Arun.
How much value? Actually, it's a lot more efficient.
It's a lot more efficient to do it this way, quicker.
Yeah, quicker.
No, usually they use all this for quick prototyping.
Quick prototyping.
Not for production.
Yes, that's right. Production it'll get there, but it's not quite there yet. Yeah. And QDrent, how many of you like QDrent? QDrent I thought was much more mature. It's ready for prime time. Right? Compared to the vector fires indices that you were maintaining yourself, it was ultimately these are layers on top of it, but it did a pretty good job. Right? So that's that. So this was the two things, few things. And Olama, how many of you liked Olama?
I tried it.
That's kind of where I was getting the issue. It's not like I can run Llama Index like with ChatGPT, but when I try to integrate it to Olama, getting it to run locally is like, for whatever reason, like the packages just don't match up. Yes,
right. It's a that's the integration help, guys. We should do this on our Slack channel. Let's have, or maybe we can have another channel just for integration. This battle of integration can only be won through collective wisdom, like collective action, collective intelligence. It's really a pain what you're going through. All of us go through. So each of us individually struggling, it's far better we share our notes. I go through the same hell, by the way. After all of these years, every time I have to make one software work with another, my stress level goes up.
I think like the one thing that's like really frustrating about it is that there's literally no documentation anywhere about anything.
Oh,
so
yes.
If you go to like the Llama Index like documentation, you're trying to figure out, okay, how can I change these configurations? No descriptions for what the inputs should be. They have like complete discrepancies between different examples that they have on the website.
Right. No, code is the example. You literally have to step through the code most of the time.
Some of the code, I think it's from older versions, and if you try to take like what they're doing there and put it now, it just doesn't
work. Oh,
LangChain is worse. LangChain is like
LangChain is a disaster.
It just changed. Just lose it.
LangChain is. I mean, I shouldn't say this on record, but LangChain code quality itself begins to scare you. Okay. All right. So, guys, these are open. At the end of the day, a lot of people have worked very hard to produce these things. Take it for what it's worth, but be careful. Okay. So, all right. So now we come to today. Go ahead.
Asif, LangChain, I believe, I think I read it right. Microsoft obviously is also getting into LangChain, and they're forming a collaboration there as well. So
yes.
things going into real heat. They're trying to take everything pretty much open source back to them.
Yes. Yeah, guys. So yeah, everybody is jumping onto all the good open source projects. Google is pounced on Hugging Face. So Hugging Face and Google have a very good deal. So good things will come out of it because Google has, I suppose, will let you run a lot of the Hugging Face models, etc., directly in the GCP cloud. Microsoft is getting into the LangChain. And so, guys, today's I'll release the PyTorch. So, guys, let's come to today. Should we take a 5 minutes break before we start with today? Let's take a 5 minutes break. Then let's start with today's matter.
I set up Llama. I set up Llama Index separately.